In this video, we're going to be doing an application problem with the composition of functions. It's about bacteria. So the number n of bacteria in a refrigerated petri dish is given by the function n of t equals 20t squared minus 80t plus 500, where t has to be greater than or equal to 2 but less than or equal to 14. And where T is the temperature of the petri dish in degrees Celsius. Now, when the petri dish is removed from the refrigerator, the temperature of the petri dish is given by the equation T of T equals 4T plus 2, where little t has to be greater than or equal to 0, but less than or equal to 3, and where little t is the time in hours. So capital T is for temperature, and little t is for time in hours. So we're going to start off by finding the composition of N composed with T, and we're going to interpret its meaning in context. And so here is our N of T, and here is our T of T. So in order to compose N of T, we're going to begin by writing our T, or our N rather. And everywhere we come to a capital T, we're going to leave a space to be able to put in our value of our T of T, which is 4T plus 2. So I'm going to plug that in. Now notice here that our 4T of T is squared, which means that we're going to need to distribute that, which you might know as foiling. So here I have a 16t squared plus 8t plus 8t plus 4. So 16t squared plus 16t plus 4. And I'm going to put that right there where we just have that. So now we have our N of T equals 20 times our 16t squared plus 16t plus 4 minus, we're going to go ahead and we're going to distribute that negative 80. So negative 80 times 4t is going to be a negative 320t, and 80 times 2 is going to be a negative 160. And then we have our plus 500. So our N of T, so we're going to distribute that 20, and now that's going to give us a 320 t squared plus 320 t plus 80 minus 320 t minus 160 plus 500, and we're going to simplify that by combining our like terms, and we're going to have a final answer of 320 t squared plus 420. Okay, so we've gone ahead and done the composite, so that's our function right there. But we also need to interpret its meaning in context, which means that we want to know what the composite function N of T, we want to know what that represents. And the composite function represents the number of bacteria as a function of the amount of time the petri dish has been out of refrigeration. Okay, so that is what our interpretation of our composite function means. Again, the composite function represents the number of bacteria as a function of the amount of time the petri dish is out of refrigeration. We're now being asked to find the number of bacteria in the petri dish when little t equals 2 hours. So it's been out of the fridge for 2 hours. So we are simply going to take our equation, we're going to take our N of T And instead of a t, we're going to plug in the number 2. So here we'll have 320 2 squared plus 420, and we'll plug that into our calculators, and that's going to give us a value of 1,700. So there are 1,700 bacteria in the petri dish. Now we want to find the time when the bacteria count will reach 2,000. So we want to know when our n of t equals 2,000. Because it's asking us for our time, that's why we're looking for our little t. So we're going to take our equation, our 320 little t squared plus 420 and set it equal to 2,000. And now we're just going to solve for our t. So we'll subtract 420 from both sides, leaving us 320 t squared equals 1,580. We'll move that up, gives ourselves a little bit more room. Then we're going to divide by 320, and we're going to be left with a t squared equals 79 over 16. So then we're going to square root both sides, and I'm just going to go ahead and do that. And that's going to leave us with a t equals, now normally it would be plus or minus, but we're talking about time. You can't have negative time, so we're just going to have the positive answer. And we're going to have the square root of 79 over 4. Now if you told somebody that it would be radical 79 over 4 hours when the bacteria reached 2,000, they would look at you like you're a crazy person. So we need to convert that into a decimal, something that people can kind of fathom and understand. So if we plug this into our calculator, right, if we put that into our calculator, we're going to get that approximately the time will be 2.22 hours. And so here we can say that the count will reach 2,000 bacteria when t equals 2.22 hours. And again, we were able to throw out our negative answer up here because a negative answer was not in our domain, because we just want positive time, because you cannot have negative time.